We're back. In our last exciting computer networks class, we had occasion to try a little distributed computing. And it was all very fun, and I thought, well, gee, isn't this swell? I think some people were using RMI to talk to my machine, and I was using RMI to talk to your machines, and we were all using the network, and it was all great fun. One of the things that we ran into when we started using remote method invocation is we had a procedure, and that procedure required that we take an instance of a plain old Java object and wrapper it so that we could invoke it remotely. And that remote invocation involved us creating what we're calling a delegate. And the delegate would message forward across the net in order to create an invocation. And moreover, if we wanted to be able to take multiple objects and bundle them together in order to have them all share methods and interfaces, we found that there was a mechanism called, anybody remember? There was a paper on this. I think it was assigned reading. Yes, CentaJ. Yes, the CentaJ paper. We used a mechanism which allowed us to generate the delegates, and it was done semi-automatically. And so we called it semi-automatic proxy delegation. And the proxy was the thing that you invoked, and then it delegated with message forwarding over to the contained instances. And so that method of delegation allows us to bridge across the network. So I thought, gee, wouldn't it be fun if you could combine semi-automatic static proxy delegation with remote method invocation? Gesundheit. So in order to do that, I had to create a lot of, I'll call it boilerplate, for doing things like talking to the registry, right? Remember what the registry is for? You take an object, you rebind it to the registry performs a lookup. The registry service runs on a machine with a specific port that it listens to. The common port for an RMI registry is port 1099. And you can go to a machine on port 1099 and you could say, hey, give me the Kyle object, right? And it comes back with an instance and says, here is an instance of the Kyle object. I could start doing invocations on the Kyle object. It goes across the network, finds the Kyle machine, and then proceeds to start invoking, and then returning instances of answers. So then I said to myself, this is a lot of work. How can people do this and make it just a little bit easier? So what I did was I wrote a Java program that generates Java programs. And that's part of what the semi-automatic static proxy delegation does already. Only this is just like it with a difference. And the difference is it targets remote method invocation. So now the delegates, instead of being local to your machine and invoking them locally on your machine, can wrapper multiple instances of classes, give them interfaces that appear to have multiple inheritance of specification, and then use a mechanism, such as topological sorting, to disambiguate the implementations that may occur when you have duplicate methods. So for example, if you have a method that says toString and it says, hello, my name is Brian, and then you have another method that says toString and it says, hello, my name is Rich, and I try and inherit, from the Brian class and from the Rich class, and then I invoke toString, what does it say? Does it say, hello, my name is Rich, or does it say, hello, my name is Brian? And the answer is, well, if you use topological sorting, the first class will override the second class. That is, the two methods will shadow one another, and you can determine which one will override the other. So that has to be done as a matter of course when you decide you're going to use topological sorting, because what happens is the order in which things occur matters. And so if I make, this happens in multiple inheritance languages like C++. If I put the Brian class ahead of the Rich class, then Brian wins. And when you call toString, it says, hello, my name is Brian. But if I put the Rich class ahead of the Brian class, then the Rich class wins, and then it says, hello, my name is Rich. So what we need to know is the order in which things are inherited. We also need to have access to all of the interfaces. So what I did was I created this sort of interesting looking thing here. It's a container, right? Here's the little vector, which is my container of instances. And to that container, I would like to add a couple of instances. And so I'll add a hello world instance and a date instance. And what I'd like to do is make a new class called the hello world date. And what it should have is it should have an interface called the hello world interface, which contains the specifications for all the methods in hello world and all the methods in date. And it should also have a hello world date implementation, which contains all of the implementations for all of the methods in the hello world class and the hello world date. And it should be able to take that implementation and run it on a server with remote method invocation, so that a client can proceed to invoke all of those methods remotely. And it should generate all of the things that I need, all the stubs, all the registry junk, all of the stuff that I'll call boilerplate or overhead involved with using RMI, and it should generate it automatically without my intervention. And if I do it automatic, then it becomes automatic static proxy delegation. Automatic because it has a policy. And a policy is we'll use topological sorting, just like real multiple inheritance type languages. Excuse me. So here's the deal. I make a new instance of my little main, which is, in case you're wondering where the heck I am, this is off in net.rmi.rmi synthesizer. And so we're going to proceed to synthesize the remote method invocation. And we'll do that here in the main. When you look at the main, you can sort of see right in here the delegate synthesizer, which has a policy being set, and I set the topological sorting to be true. And when I do that, I'm basically saying, yeah, order matters, and a hello world date is different than a date hello world, because of how toString will shadow and override the other toString method. So let's just run it and see what happens. Nothing. Oh, it works. So let's have a looky-loo and see what we can see. I'd like to see sort of the structure, and it says here I've got this new thing called the interface with a peculiar name, and it's called the date hello world stub. And what it contains is the multiple inheritance of specification that you get when you have the specifications for the date stub and the hello world stub mixed together. So we're mixing these things in. And so now to get the date stub, what we want is to use reflection to go into the instance of the java.util.date class and grab all the specifications that we can find and list them as part of the interface that's needed in the implementation for the date stub. And so we can state all of those specifications automatically by using reflection. So this is every single method in a java.util.date. Stop me if you have questions. There's a hello world class, and it has methods, including main, which have been emitted by the synthesizer. So the synthesizer says, okay, here's the interface for the hello world stuff. RMI is not present here, right? So far, all we're doing is we're creating two separate specifications and then mixing the specifications together, right? No RMI here. Nothing up my sleeves. Then comes an implementation for the date hello world, right? And so the constructor requires an instance of the date, and we're going to message forward to that. It requires an instance of the hello world, and we'll message forward to that. And these two instances will be stored locally for us so that we can have access to them. And then what we'll do is, if somebody wants to call equals, we'll use the date equals because it appeared first. If someone wants to call toString, we'll call the toString on date because it appeared first. That's what you get with topological sorting. That means that if I put date second, it would call the hello world toString first instead of the date toString. In other words, behavior changes when you change order. So all of the invocations here are implemented and borrowed from the containing instances. The relationship here is called composition. Composition is also the same thing as has-a, right? As an object-oriented designer, it's often the case that we have something, but we do not inherit the properties from it. For example, animals are a superclass. A subclassification for animals might be mammals. A subclassification for mammals might be humans. We know that the cardinality of the set of all humans is smaller than the cardinality of the set of all mammals, right? Because subclassifications are like that. And what they say is a human is a kind of mammal, and a mammal is a kind of animal. And therefore, they can inherit the properties from one another, and they create what's called a taxonomy. It's a directed acyclic graph. Not all directed acyclic graphs are taxonomies, but all taxonomies are directed acyclic graphs. And what that means to me is you have a computer science tree where all the arcs have arrows, and they all point away from the root into the children of the tree, and that none of the leaves on the tree connect with one another. That's what acyclic means. Otherwise, it would just be a general graph. If the leaves connected, it would be a general graph. So now, when you think about it, if I had a pen, wouldn't make sense to subclass human in order to call it the, let's say, human pen, because a pen is not a kind of a human, right? To say that I have an instance of a human called a Professor Lion, and then Professor Lion has a pen, is really different than saying the pen is a kind of Professor Lion. That makes no sense. And so, as a result, it's not a correct way to represent knowledge. You do not subclass a Professor Lion in order to give the attributes of Professor Lion to the pen. Instead, what you do is you say, oh, Professor Lion has a pen. And some of the properties of the pen, that is, it can write, the pen writes, and perhaps Professor Lion writes with the pen, those are very different things than by saying, well, I'm going to say all mammals have hair, therefore the pen must have hair, right? Or the pen gives live birth, or is warm-blooded. It doesn't inherit the properties from a mammal because, well, it's not alive. It's just an inanimate object. It's just a pen, right? So it's very important not to do subclassing inappropriately just to be able to inherit the features, right? That's not good object-oriented design. It doesn't properly represent the knowledge. So what I've done here may be an improper representation of the knowledge. I've made a hello world date, and I've combined properties from both, right? But I did it for a pragmatic reason. Here's my hello world instance. And now I've created a server, right? And the server proceeds to deal with the remote hello interface. It gets the registry. It does the binding. And now I can create an output for a client. Let's see if we can do that. Here's my, is this print statement being used? Yes, it is, m.print. So here it says get server, m.get client. Now the client, when you look at it, it's null. And it says, for example, see RMI hello client. And so now if you look at, is there an RMI hello client? There may not be. There should be, but I don't see it. Bear with me just a minute. It says see RMI hello client. Let's just put that in there. There it is, RMI hello client. So here's the RMI hello client, and what he's doing is he's doing a lookup using the remote hello name on the local host, and then he's doing a remote invocation by calling remote hello client RHC dot test get message. And what test get message does is it goes to the remote hello and calls get message, which apparently returns a string and then prints it out locally. And you can see there's no implementation shown here because this is giving us only the stub. That's giving us the, I'll call it the remote hello interface. So something must implement that interface, I'm thinking. And we can find a remote hello implementation which implements that interface, and sure enough, when it calls get message, it returns the message, which says hello world. So that's kind of interesting, right? It's using a unicast remote object. What does that mean to me, the RMI programmer? Unicast. Point-to-point TCP/IP protocol. It's doing a straight invocation and returning a serialized instance. The string is serializable. I'm able, in effect, to remotely invoke this remote hello implementation by making reference only to the remote hello interface. And so the implementation gets invoked on the server. Let's see if we can find usages for the server. Here's the server. The server starts off by gaining access to an RMI registry, and then it proceeds to rebind the instance of the hello implementation to the name remote hello, and that's bound to the local machine using the RMI protocol. And when you think about OSI model for the layers, what layer are we in when we use RMI protocol? Well, the transport layer would be good for flow control and point-to-point bit transport. So TCP IP gives me services like being able to put bits at one end and having them come out at the other end. So that gives me a pipe, a bit pipe or a stream. And when I think about a stream, I think about an unformatted sequence of bytes. And so when I'm using RMI, I'm really working with strong types. And that's so important for me as a programmer, because if I pass the wrong type through, hopefully the structure of the specification will give me a warning at compile time. Because I'm using strong typing in my specs, I would like to think that if I'm passing in an instance of payroll, and instead I pass in something that's not a payroll, the compiler will complain to me. I can't just I'm not at liberty to expect payroll to come back when this thing says I'm only going to have a string, right? So I have to process it as though it were a string. So I have strong typing. So I've got to go beyond the transport layer, I think. So what's the next layer up? Right? Let's just think about it. We'll go through the layers together. At the bottom, I'll call it the first layer for no particular reason. Physical layer. That's where energy is moving from one place to another that allows us to transport bits. In the field of communication systems, an electrical engineering field, we study things like radio, and we study things like light, like fiber optics, and we study things like electricity, like Ethernet. And so Ethernet might be a common baseband communication system which allows us to assert a series of ones and zeros, physical layer. Then comes the data link layer, which allows us to do link access protocols, including point-to-point protocol. And these link access protocols can do error control. They can do flow control. They can do things that include dynamic back-off of packet size, especially if you're going across a modem that might have a noisy phone line. You might say, geez, these packets are too many errors. Let's shorten the packets because we have to do retransmission requests. In your data link protocol, you might have RS-232 ports, which we discussed last class. Next, right, RS-232 ports are pure point-to-point. Right, you have data communication equipment and data terminal equipment, and that's it. Another layer up, that's going to be your network layer. That's where your routing occurs, and that's your Internet Protocol layer, IP. And on top of IP, you can have connectionless protocols, UDP IP, which include multicast, or TCP IP, that's Transmission Control Protocol. And so now you have a transport layer and transmission control protocol. Now on top of that, right, so now we're up to layer 5. And now I'm thinking maybe there's a session layer in there, which allows us to do things like login control, to initiate password transport. And then on top of that, we have another layer. We'll call it, is it layer 6? We're up to 6, I think. Right? So we had physical layer, data link layer, network layer, transport layer, and then comes session layer, and then 6 is going to be your presentation layer, right? And then after 6 comes application layer. And so with presentation layer, you have hypertext transfer protocol, which is really very good for moving things like HTML, which you're all very familiar with now, right? You guys are probably born using the internet, right? So at some level, I didn't have that, right? We didn't have punch card machines when I grew up. We had to punch the cards with our teeth. That's what it was like when I grew up. So as it happens, in presentation layer protocol, higher level protocol, I could place RMI squarely. And the application that I'm running on top of RMI goes in the application layer. So that might be a distributed file system, for example, or a multimedia transport system. So now we've gotten nice real-world applications for all the layers, and we can touch them. We can touch these layers, right? They're physical for us. Even the wireless layers can be physical for us, right? Because if you think about it, you can reach out and touch the antennas for your Wi-Fi systems. I mean, real physical things are happening there. So I like to think about this as being in the presentation layer because of the strong typing. And I feel that the strong typing is a most definitively an important service, because otherwise we don't really know what kind of data we'll be sending or what kind of data we'll be receiving. Remember, in a network of workstations, every single computer runs asynchronously with respect to every other computer. So you never know what's going to be communicated to you. And so having these, I'll call them strong types, is kind of important, I think. Yes, sir?
Could you talk about strong?
Who?
What do you mean by strong type?
Strong typing. So for example, if I tell you that the only thing you're getting is bits, and then it's up to you to figure out what the order of the bits is in, and whether the bits are part of a byte or part of an int or part of a char or part of a payroll, then I'm not giving you very strong typing there. I'm giving you kind of weak typing, and you can do whatever you want to with the bits. That freedom, right, to do whatever you want to, is actually not good. You don't want that freedom. You want to know that what is being passed in is of the correct type, because it's hard enough to debug these distributed systems without having to guess what the type was being invoked on. Think of it a different way. If I, as a side effect of calling a subroutine, modified municipal memory, it would be the equivalent of my turning off the lights and having random people draw stuff on the whiteboard and then turn on the lights and trying to figure out who did that. You know, who wrote this there? And if I had that communal memory where anybody could write anything at any time, because you've got so many workstations all contributing to the data structure, that wouldn't be good for me because it would make debugging so hard. So it's really very good to know these types, these data types. So they're reference data types, but they're structured data types. What do you think of that? So now we've run the hello server once already. Let's just run it again. And we also saw the singleton design pattern in the RMI registry utils. Oh, here's where I've added my little RMI client invocation. Here, let's get rid of that. Can somebody remember what the singleton design pattern is for?
One class of one object.
Yep. Singleton is the pattern to have when you're only having one. And peels is the beer to have when you're having more than one. Right? Beer to have when... Have you not heard this? Oh, no? Really? It's true. It was a commercial. Oh well. Before your time.
I thought there was another object-oriented design pattern.
No. Have you not had a Peel's beer? They may not have that anymore. Anyway, I think it was Peel's. Oh well. And Schlitz. They were competitors. I got sidetracked. So anyways, how would we implement the get client invocation? You can sort of see get client just returns null. Can I assign it for homework? You guys can output the get client code. You can sort of see the different pieces here, right? Something starting the server. That's a mouse event server, huh? Let's see now. I got a date. I got a hello world. I got the interfaces. What else do I need? I got a server. Now, why is the server called the RMI mouse event server? That doesn't seem right to me. Call server. He gets the hello world interface. Remote hello implementation. Does a rebind. Yeah, I'm not liking the name. This name just doesn't seem right to me. Where does it say get server? Right here. Did I hard code the name of the class for no particular reason? Yes, I did. So that's not correct. We'd want to give it a better name.
What's wrong with your name?
RMI mouse event server? It's not a mouse event server. It's a server that combines the
Hello date?
yeah, the hello world and the date. If anything, it would be a hello world date server. I should probably set the server name, but that's probably no different than hard coding it. Although my thinking here is that you can derive the server name the same way you derive the name of the interface. Excuse me. There. That fixes that.
Yeah, I agree.
You know, that's not a good name. Let's see. It says get implementation. When he gets the implementation, he does delegate synthesizer to string, and then he extracts the implementation. And now here you can sort of see he's getting he's doing a little string manipulation. And he's giving me substrings in order to get things like interface names. Here you can see where the interface is obtained. Since he's giving you the interface, you could use the interface name as the name of the server. Let's see what the interface name turned out to be on this. I think it was called Hello World Date Stub or something. I'm not convinced that's a good name either. Should it be called the Hello World Date Stub Server? That doesn't sound good. We could find better names for these things, I'm sure. Maybe it should just be called the Hello World Server. That'd be good, I suppose. So there's a couple of ways to go on this. I'm calling the entire example an RMI synthesizer because what it's doing is it's giving me the scaffolding to remotely invoke plain old Java objects. So you, as Java programmers, will be writing code, and you'll be wanting to remotely invoke that code. And the way you would do that is you would wrapper it. And so then the question is, how do you do that kind of wrappering so as to make it relatively automatic? And my answer to that is synthesize the code automatically using reflection. The question of whether or not this is good enough is another matter, right? Maybe it certainly isn't. Here is here's the RMI server. It says get server factory. I got another one here called RMI client. Let's see what else we got. Here's called host manager GUI. This one I'm not sure about. I'm going to just run it for fun. Oh, I forgot what I did with this one. Let's just look. Huh, Synth-J web interface. Okay, that's cool. I'm thinking that an RMI synthesizer is one of those things that you guys would have a lot of fun with. That is to say, you would be able, I think, to synthesize the RMI code in a semi-automatic way, just the way I have done here. Now here's one that's called asynchronous RMI. Let's see what this does. Oh, alright, I remember now. Asynchronous RMI is the one that uses threads in order to remotely invoke stuff, and then it returns the primary thread of execution right back to the invoker. I'll call that an advanced topic, not for you guys. Let's see if we can do another one. I'm going to go and change the interface here so that it uses something not a date. Let's not use the date. Let's make a frame. Oh, I know. Yeah. Frame F equals new frame. Alt enter. Alt enter. You know, the thought occurred to me this should be a J frame for swing. Has everyone here had an opportunity to try and do something with swing in Java? A little bit. Does everybody know what a J frame is? Right? The J frame, that's something that you can display, you can resize. Wouldn't it be fun if the J frame had can you do something like get content pane and then get graphics? Yes. And so if I have the graphics context from a J frame, graphics G equals alt enter. So here's what I'm thinking. Wouldn't it be swell if we could take a graphics context and remotely invoke it so that we could draw remotely on somebody else's screen? I'm not hearing a yes, Professor Lyon. How swell that would be. Yeah, isn't that swell? What a good idea. Because if you can draw on somebody else's screen, what does that mean you could do?
Write down messages.
You could write the messages. Write the messages. How fun! Ooh, write the messages. How about games? You could have a remote screen that has games on it. You could do graphics remotely, right? You could remotely display stuff, like the answer to some image processing or image synthesis.
Tic-tac-toe.
Do what?
Tic-tac-toe. Right?
Tic-tac-toe. You could do tic-tac-toe. So I'm thinking that if I just wrapper the graphics class, what could possibly go wrong? Let's find out. I've never tried this before. Something bad will happen. I didn't initialize it? Really? What if I just gave it the frame to play with? Well, maybe I had to show the frame before I tried to get the graphics context. That might make sense. Yeah, so the frame worked. But I'm not convinced that graphics is serializable. Instances of graphics probably cannot be returned. But it has every single method inside of the frame, and it's all in here. And it's called the JFrame stub. That's pretty cool, actually. So if I wanted to do this with graphics, there's probably something that's preventing me from instancing the graphics class. I'm going to say it's because I didn't show the frame. F.set size to be 200 by 200, and then F.set visible to be true. And now we'll get the content pane, get the graphics, and let's see if that works any better. I could be wrong about that. Yeah, I was right. How about that? So now I've got, let's see what it printed. This is pretty cool. The name of the graphics context was Sun Graphics 2D Stub. And this contains every single method in the graphics context. And here's the constructor, which requires a graphics instance be passed. So for this to run on the remote machine, the server would have to create a frame, set the size of the frame, show the frame, make an instance of, or get an instance of the content pane, go to the content pane, get an instance of the graphics context, then construct the server. Right? It's so important that when it's remotely invoked, it actually has a place to do the drawing. So it will be the frame on the remote machine. That's key and clear, right? Everybody understands that you must have a frame before the graphics will start to be drawn. Then, this is the implementation, so it's message forwarded. And now here's the RMI part. I don't know why we're still calling it an RMI mouse event server. Start server. Take the remote hello implementation. Get the registry. And so now we're ready for the client to start remotely invoking methods in the server. So what's missing in all of this? You guys are so quiet. I can't believe you're not, sort of getting it. Or are you getting this? Who's lost? You're not asking questions. I'm asking questions. You guys aren't answering any questions. So that's not good. Kyle, what's missing? I don't know. Okay. Let's go back to the basics, because it's clear that there is stuff missing, but you guys are not kind of seeing it or getting it or something. Let's see if we can get some examples. So we got to have an interface for the remote class, and I've shown you how to generate the interfaces. You've got to have the registry, and you've got to register the server with the RMI registry. That's fine. You've got to create the client, so the client is clearly missing. But there's more that's missing. Every one of the proxied message forwards has to be done through a throws a remote exception type interface. So the interface has not been throwing any remote exceptions that you noticed. So that's missing. Also, the interface has to extend the remote interface. That's key. And it wasn't doing that either. Let's see if we got some good examples here. So here's a stock market implementation, and what do we see? The implementation throws a remote exception. We didn't see the remote exception being thrown there, so that's missing. Let's see now. Here's the interface here, and it has to subclass the remote interface. That's key, because if you don't have that, it ain't going to work. So far when you saw that interface, you didn't see it extending the remote interface. So that's missing. So far we've got a few things missing. The interface also has to define a specification that throws the remote exception. Also missing. So a couple of things are missing. Let's see now. The implementation has to subclass the unicast remote object and implement the remote hello interface, which remember subclasses the remote interface. So that was not there either. So a couple of things are missing there. Let's see what else we got. The client. Here's the client. So the client needs to have a notion of what the name is going to be of the remote object. That remote object during the synthesis phase has to be used to create the client so that the client can properly look up the remote object. So I'd like to know that I have a name which is consistent with the name of the class that I'm instancing. I don't think it should be identical, but it should be consistent. So how do I get the name of the class? Right? Somebody passes me an instance. What do I do? Yeah, do a instance.getClass. Then I do a, let's assume the class that's returned is stored in a variable of type class whose name is C. I can do C.getName. Right? And now with that name, I have a name for the class which is the same name that the class is using, but I need to create a new class. Right? This is the remote implementation. So maybe it's if it's graphics, I don't want another class named graphics. That would suck. How about if I called it graphics remote, or graphics RMI, or graphics whatever you like? So I'll have to have a graphics remote interface, a graphics remote implementation, and then in principle I'll need to have some sort of client which is going to start drawing on my remote graphics context. That's kind of important to me because otherwise I can't do my graphics remotely, right? Let's see now. What else am I missing? Anything? That's all I could think of at the moment. You'll have to start the server, rebind the remote object, and then you can run the client. You'll have to do a lookup that's consistent with the name that you've decided to select, whatever that name may be. Graphics remote, or remote graphics. I don't know what to call it. Remote graphics? Graphics remote? You'll have to know where, right? You'll probably run it on your local host. That's fair. I mean, obviously you could run it on a different computer, but it might be okay for you to run it on your local host. Why not? Just especially when you're debugging. You're going to have to run your registry, but you can use registry utils to do a get registry, and that'll get the instance using the singleton pattern, design pattern. What else do you need? think that's it. Is the PowerPoint online? I don't know. The paper for doing this was online. We can put the PowerPoint online. Let me see. Let's see. And also, it's chapter 43 of the book. Huh?
I feel like the book is always different.
Different?
Yeah.
In what way?
Less condensed and difficult.
So there should be a way to upload this. Does anybody know how? So I got assignments, content, file, select file, browse my computer, J for P, chapter 43, RMI, name, chapter 43, and submit. There. How's that? There's chapter 43. So you can look at it as though you were looking at the midterm assignment, for example. What do you think of that? Does that work for you?
Yeah.
I'm still learning, okay? Blackboard is still very new for me. What else can we do? Oh, and there was some nice papers on this, right? So if you went to the DocJava website and you looked at the papers, journal papers, and you went to here it is, Centa-J and RMI code generator. You can sort of see the same implementation that I'm trying to describe for you now. Was it assigned reading? I think it was. Yeah. So in theory, you should have been able to run it, or at least read it, and then what else? This is too many. Here it is. Here's some code. RMI synthesis, the time server interface. So if you wanted to find this code, time server, you could probably find it any one of a number of different ways. My favorite is to do a find in path, and then type in something like time server and do the whole project and hit find, and there it is. Here's a daytime server. Not sure if that's the same one. Let's see what else we got in here. I'm going too fast through this. Time client, student vector. What is the issue here? Student vector proxy. It looks like it's outputting delegate synthesizer. I'm just sort of running through this
proxy, add proxy, get interfaces. Let's see if we can find I'm just going to look at this real quick. It says here there's a thing called proxy, and I just wanted to see if I could find it. Edit, find, in path. You know, I have so much trouble with this trackpad, and I got a mouse, so I might as well use it. Proxy. And whole directory, find. Oh, there's a lot of them. Sample RMI. There's just too many proxies here. It's a common name. I guess I shouldn't have used that name. Here it says RMI graphics. Yeah, that's not the one I want. Sorry. So I'm thinking this, that if you guys wanted to, you could probably take a stab at generating the RMI code that would be needed to finish up the example. And what you've got is sort of the structure for a framework that would let you output all of the RMI accoutrements that are needed in order to do the remote method invocation. We could start with something much simpler than the graphics instance, because that one has just a ton of stuff associated with it. And I'm thinking something like the Hello World instance is a better way to start. So let's get rid of the frame, and let's just make Hello World something that you can invoke remotely. That makes life a lot easier looking, because all you really want to do is generate the stuff that you already know about, how to generate RMI versions of Hello World. So what do we got? We got the Hello World stub, which extends Hello World stub. That doesn't sound very educational. We probably don't need that. What was the thing we were adding here? An instance of the date? We can do that. v.addElement. Oh, I know. Let's take in two different classes. One called Hello World and another called Goodbye World.
Do we have this code?
No, I'm going to write it for you right now. It's called Goodbye World.
No, do we have like the Hello World?
Yes, Hello World is in there. It returns Hello World. It's in net.rmi.armi. And Goodbye World is just like Hello World, only it says goodbye. There. And so now what I'd like to do is I'd like to make a Hello World, Goodbye World class. And I'd like to remotely invoke it. So let's see if we can generate the Hello World, Goodbye World interface. So that's what I'm thinking. So what I'll do is I'll make a separate class instance called goodbye world, GBW, equals new goodbye world. How's that? And we'll go to the vector and we'll add the element goodbye world. There. And we'll get the implementation, the server, and the client, and show it. Let's see if this works. Okay. So oh boy, this is some name, huh? It's the Hello World Goodbye World stub, which subclasses Hello World and Goodbye World, and contains the same exact methods in both. Right? It's part of the same specification, but remember, because of topological sorting, since Hello World came first, Hello World wins over Goodbye World. So we've got an instance of the Hello World Goodbye World implementation. Its constructor needs both an instance of hello and goodbye, but when somebody calls the main, it favors the Hello World main over the Goodbye World main. And when they call get message, it favors the Hello World get message over the Goodbye World get message, because Hello World is first. And so Goodbye World is practically unused as a result of the fact that there are no methods in Goodbye World that are different from the methods in Hello World. But that's fair, and that's expected behavior. So now comes the server. And the server looks like he's rebinding. And now we know what's missing. Right? We were supposed to throw remote exceptions on the stubs, but they weren't done. We didn't throw any of the remote exceptions. But you guys can put that in there because it's just a string. Right? And in fact, if you think about it, it might be okay to, in the first pass, to just hand code everything. So for the purpose of an exercise due next week, turning I'll call it, what is the name of this thing? The Hello World Goodbye World implementation into a remotable implementation that you then can proceed to remotely invoke. What would you test? If when you write your client, what would you do to test the client, to generate the client?
Make sure I can talk to the server.
Yeah, you want to invoke something. Probably you want to get the message and print it out at the very minimum. So what I would do in a case like this is write it up. Let's see now. What else do you need? I'm liking the idea of just uncommenting this for a good time. And commenting this out right up in here. Because I'd like to see what it does when I do it. Just for fun. I think it'll still work. Yeah, it did, actually. So, what do we got? one interface that subclasses two interfaces that have the specifications for both class instances that have been passed in, an implementation, hello world, goodbye world, which does message forwarding. And what's wrong with what we have? And the answer is your constructor has to throw a remote exception. Every single one of the methods has to throw a remote exception. All of the things that you do to that wrapper, which contains both instances, will leave the instances unchanged. Right? So in other words, you're not having to modify your original code. And that's critical. So if the original code is seen as the hello world code and the goodbye world code, being able to mix the two things together and make them remotely invocable without having to modify either program is critical, because both programs could be used by the software shop. They could be actively employed in some other role. So by turning these things into something that can be remotely invoked, you add a little value, right? The value added is now that you can do distributed computation. Now you could say, but Professor, they're so trivial. This will be easy. Is anybody going to say that? No. Nobody says that. Nobody's saying that. So how shall we write this up? I'm sort of thinking out loud. We can probably take the original code here, copy it, put it into Blackboard, where are we? Computer networks, right? Here we are. And then it should be possible to add an assignment. What number are we up to now? 5? So I click on assignment, nothing happens. Homework 5. RMI. Use the below code to generate a, what are we calling it? Hello world goodbye world class that can be invoked remotely. You will need to throw remote exceptions for each method. Whoops. You will need to throw remote exceptions for each method you plan to invoke remotely. Your client will need to use a registry to look up the server. Okay, that's fair. What else do you need to do? Oh, invoke the get message and print the result on the console. Is there some way to turn off the trackpad? It's just so spurious. The console. So, do you have to use my delegate synthesizer code and all the reflection util stuff that I provide? And the answer is no. You don't have to. You may find it easier to, use your own thing. I've got reflect utils getting me instances of all of the methods that I think are of interest, all the public methods and their method signatures, and that's what's used for the synthesizer. That's how I generate the RMI type code. So you might say, well, gee, I find it harder to read code than it is to write code. I'll just write my own. That's fair.
Can we just do it manually by, for this?
Yeah, for this, okay, great. For this example, you may implement the code manually. I.e., you do not need to synthesize the code via automatic technique. Well, via automatic, well, how about this? You do not need to synthesize the code automatically. There. So that makes it easier, right? Because now all you're really doing is you're writing a hello world invocation, which kind of mirrors what's in the book already. Right? It's just like chapter 43, which presumably you have all read. Right? Maybe not. Some of you have read. Well, look, feel free to read chapter 43 and follow the example there. So that'll motivate you to read the book, just in case you haven't been reading it. Anyway, this should get you started with RMI, and that's kind of what I'm doing, is I'm giving you the hello world of RMI. And we'll make it due in a week, and my plan is to continue along this vein so that you all can have actually, no, it doesn't start at 5. It starts at 2. We'll make it due at 2 so that you all can have a nice RMI experience. Is there class next week?
Yeah.
There is.
There be?
Huh?
Why wouldn't there be?
I don't. Someone said something or other about Easter break or Palm Sunday or what's Monday?
We're good.
So we're okay, right? Yeah. Yesterday they said there was no class next week, and I said that can't be right.
We can skip class.
You can skip. Right. Yeah. Someone said if the professor says there's no class, then there's no class. Okay. They have a very liberal sense of what is a proper way to schedule a class. All right, so I have done it. I've submitted it as a homework, and we're calling it Homework 5 RMI. And I thought what I would do is use this time to take a logical break. Is it break time already?
Yeah.
Logical break. But what I'm thinking is that I should also make mention of the fact that there is an open house tonight, and I'm hanging out with the incoming graduate students. That starts at 6, so if somebody needed advising for some reason, I would be available after class today. So, huh?
Can we do that?
Yeah, absolutely. So anybody who needs, to have, let's say, their graduation paperwork vetted, because some people have had issues with their paperwork this would be a good time to talk during the break while the office is still open. So if you have your paperwork with you, we should go down there and deal with it now. And let me just sort of stop the recording because this is not something for the